In this video, we're going to solve two problems, which are the Wingard credit union scenario from supplement B about waiting lines. So the first problem is about arrivals and calculating probability of arrivals. The second problem is you have random service times with an exponential distribution, and how do we calculate some probabilities about service, how long it takes to service someone and how many people we can serve. Now, the relevant slides for these problems are given in the Supplement B lectures. If you go to customer arrivals, it talks about the distribution, then it gives you an example of how to use the distribution, and same thing for service times. It gives you the distribution and an example that uses that distribution to calculate probability. So these examples can help us solve these problems. Okay, so let's start with the first problem, okay, which is this one. Wingard Credit Union is redesigning the entryway into its bank of ATM machines. Management is trying to understand the inter-arrival of individuals, which has been described to them as following a Poisson distribution. So on average, 6 customers arrive per minute. So that's lambda. So if you look at the exponential Poisson distribution, this is the distribution. There's a parameter called the lambda, the Greek letter lambda, and that is the average arrival rate. Okay, and so we can write lambda is 6, and this is customers per minute. So they arrive with this arrival rate randomly during busy times. Calculate the probability that during a specific minute, no customers arrive. In other words, what is the probability that 0, we sometimes call this probability P0, 0 customers arrive within a time period T of 1 minute. So this is our time window, 1 minute. This is the lambda. What is the probability that 0 customers arrive? Now notice that the time units of lambda per minute has to match up with the time units of T, which is minutes. You cannot have lambda in minutes and T cannot be 1 hour. T would have to be converted from 1 hour to 60 minutes if it was 1 hour. And so the time units have to match up, okay? And they do in this problem. So if we go to our slides, the probability of P for any value n, which is how many customers arrive, for us n is 0, is this equation, okay? So P0 will be lambda times T raised to power 0 divided by 0 factorial times the E value, which is this constant, raised to this certain power. Now we can simplify this when n is 0, because anything raised to power 0 is simply 1 and 0 factorial is 1. So this whole thing just becomes 1. But I am still going to put in the formula so you know how to use the formula in case n is 1 or 2 or some other number than 0. Okay, so I'm going to calculate this part first, then I'm going to calculate this part, then I'm going to multiply the two together, because in Excel we can break up our calculation into parts. So for this part, we have lambda T raised to power n over n factorial. Okay, so I'm going to do part 1 of my calculation, which is lambda multiplied by T, or maybe I should put n here. So n is 0, that 0 customers arrive, and we have to find P0. So part 1 of my calculation is going to be lambda multiplied by T raised to power n, which is how many customers arrive, divided by, and just to be sure, I'm going to put brackets around all of the numerator, the top part of the equation. So this ensures that this whole calculation is done before the division happens, right? So I want to make sure I complete the raised to power n and then do the division. I don't think here brackets are strictly necessary, because I believe Excel does do the raised to power operation before division. But instead of relying on my memory or relying that Excel maintains that behavior, I can just put the brackets in to make sure it always happens. To calculate factorial, we use the FACT fact function in Excel, and we give it the value of n, which is 0. So this should evaluate to 1, which it does. And then part 2 of the equation is this, e raised to power minus lambda t. And so we'll calculate that. part 2. That's e becomes exp. Exp is exponential. So e raised to power something, you just do exp and you put the power in brackets. So we have minus 1 times lambda or minus lambda times t. Okay, so that is part 2, and then my answer P0 is simply part 1 multiplied by part 2. Okay. Okay, so let's go plug that in. No customers arrived. So we need to enter it as a percentage. Remember, probabilities go from 0 to 1. Percentages go from 0 to 100%. Could be even more, but when you are representing probability as a percentage, the highest is 100%. And so when you have a probability like this, you have to multiply it by 100 P0% to get it into percentage scale. Okay, so that should be 0.24 rounded to 1 decimal place, so that should be 0.3. Okay, because if you use the Excel rounding, Excel hiding the decimal, show fewer decimal places button, it's going to do the rounding for you, and to 2 decimal places is 0.25, but to 1 decimal place, Excel makes it 0.2. Why? Because Excel knows that it's 247, it's not 251. 251 rounds to 0.3, 247 should round to 0.3, but here they do the old school type of rounding where to round 0.24, first you have to round the 4 rounds to 5, and then 0.25 rounds to 0.3. If we enter 0.2, if you enter 0.2 on an exam, I would mark it correct, because this could round to 0.2 or 0.3 depending on how you do your rounding. So if on the homework, if 0.2 is marked wrong, you can try rounding it with f.25. So treat the answer as 0.25, and then 0.25 rounds to 0.3. Okay. Usually, which is why to avoid this sort of issue, I usually always ask you in an exam to put answers around to 2 or 3 decimal places. The probability that between 1 and 4 customers arrive during a specific minute. Okay, so between 1 and 4, I'm going to assume it's inclusive of 1 and 4. So that's going to be P1, plus P2, plus P3, plus P4. So 1, 2, 3, or 4 customers arrive in a specific minute. Okay, so we can do this calculation in a table and then sum it up. So let's put n here. Okay, so my n is 1, 2, 3, or 4. Okay, then I can calculate part 1, part 2 of my equation, and then my P of n is just going to be, just like I did before, part 1 multiplied by part 2. Okay, and I can compute P of n for P1, P2, P3, P4. Okay, now part 1 is this equation right here, so we can just copy it and change the n. Okay, and so I'll put it here. Okay, and now I have to move this n. It's not 0, it's going to be n of 1. So I can just move it. So it's going to be b2 times b3, that's lambda times t, raised to power n, which is 1, divided by factorial of n, which again is going to be this number right here. You can just retype the formula like I did before, and just use n from here, and that's going to be your part 1, and you can compute part 1 for all of these. So but first we need to enter dollar signs to make sure that these two don't move, because if I just drag the formula down, you'll notice that the lambda cell has moved down. So instead of B2, B3, it's become B3, B4. So I have to go here and in Windows press F4. Oh, I'm pressing the wrong button. So it is, what's up with my keyboard? Okay, I had to press Fn. The function key to get the F4 functionality. So you're going to lock in these two so they don't drag down. N needs to go down when you drag the formula down. N needs to move down. So B13 should not have a dollar sign. And B2 and B3 should have dollar signs because you don't want those to move. Those should be locked in. Okay, and now when I drag it down, I should get the right calculations, right? And you can see that's using lambda and t from up here and n from down here. Now part 2 is the exponential part, which is exponential minus lambda t. So again, you can just put in dollar signs, and then you can just copy paste this formula here because it doesn't depend on n. So actually it's going to be the same value. Hold on. Yeah, e to the minus mg does not depend on n. Okay, so it is going to be the same value, and you multiply this by the part 1, and you get p of n going up like this. Okay, and you can just verify there's no n in this part of the formula. This was part 2, and then this was part 1, right? So we calculate it in 2 parts, multiply the parts together, and you get p of n. Now the probability that between 1 and 4 arrive, probability n is between 1 and 4, is simply going to be the sum of these probabilities. Okay, so that's 0.28. However, the problem wants us to enter this as a percentage, round to 1 decimal place. You multiply this by 100, you're going to get 28.3%. Okay, and so that was all the entire question. So you can just easily, using Excel, calculate P0, multiply it by 100 to convert to a percentage, calculate P1 to P4, sum them up, and then multiply this by 100 to convert to a percentage, and you are done with this problem about arrival probabilities. Okay. Now we're going to do the second part in a way of the same scenario, same Wingard credit union. Now we're trying to understand how long the customer spent in front of the ATM, benefiting from the service the ATM provides. So the service times follow an exponential distribution. Average customer taking 4.8 minutes to complete a transaction. So if you go to the service times distribution, okay, it's this equation right here. And if you look at the example, okay, you know that mu is the service rate. Okay, how many customers you serve per time. Doesn't have to be per hour, can be per minute, depending on whichever time units you're using. So we have to find mu before we can use this probability distribution to find the probabilities. Okay. Okay. So average customer takes 4.8 minutes to complete a transaction. Calculate the probability that a customer will take less than 2 minutes, or a customer will take more than 7.5 minutes. Okay, so we have to work in minutes. So we need to find mu. Mu is our service rate. Okay, mu. We need to find it in how many customers can we handle per minute. So one customer takes 4.8 minutes. So how many customers do we handle in 1 minute? That's going to be 1 divided by 4.8. Okay, that's going to be your mu, or 0.208 customers are processed per minute. This is customers per minute, right? This is your service rate. Okay, if you want to do mu in hours, you could do 60 minutes divided by 4.8, the average time a customer takes, and that will be, you do 12.5 customers per hour. Okay, but I don't want to do mu in hours because I have to find probabilities about customers taking 2 minutes or 7.5 minutes, things like that. So I'm going to keep this in customers per minute. So you do 1 over average time taken in minutes to do customers per minute, or 60 minutes divided by average time taken in minutes to do customers per hour, right? So that's how you find mu. Now that we have mu, we can calculate the probability. So probability time taken is less than 2 minutes. So your capital T is 2. Okay, that is, if you look at your slides, you find probability that the time taken is less than some constant. This constant is 2 minutes for us, and then you do 1 minus e raised to the power minus mu times t. So straightforward calculation. This probability that takes less than 2 minutes is going to be 1 minus e is exponential, e raised to any power minus 1 times mu, that's minus mu, times t, which is 2 minutes, okay, that gives a probability of 0.34. Okay, and we have to enter it as percentage to one decimal place, so that's going to be 34.1%. Okay. And now that will take more than 7 minutes. That's very interesting, more than 7.5 minutes. We can find the probability that something takes less than 7.5 minutes. We'll do that first. That's going to be the same formula, okay, except, we have to make sure we use this mu, so let's lock it in with dollar signs, except the 2 minutes is going to become 7.5 minutes, right? So probability less than 7.5 minutes. That's this probability, but we don't need the probability of being less than 7.5 minutes. We need the probability of being more. So the probability of being more is just going to be 1 pt is bigger than 7.5 minutes. Is simply going to be 1 minus the probability that t is less than 7.5 minutes. Okay, and if you don't know why that is true, you need to go back and take the stats course, which is a prerequisite in the prerequisite sequence for this course. So the stats course will teach you this simple probability manipulation. And so we just do 1 minus this probability to get the probability that it's going to take more than 7.5 minutes. We have to enter as a percentage or into one decimal place, so that will become 20.96. So actually, if you run it to one decimal place, it becomes 21. So let's try 20.9 and see if it works. And if it doesn't work, it'll have to be it might be expecting 21, because 20.96 rounds to 21 because the 9 rounds up because of the 6. This 6 is bigger than 5, so the 9 rounds up and then it becomes 10, and then the 1 goes there to make it 21. So let's try 20.9 and see if it accepts this. If not, we'll try 21%. Okay, it accepted that. So that was that for these two problems about how to use the probability distributions to calculate probabilities about how many customers will come or how many customers will take more or less than a certain amount of time.